Okay, the next type of the differential equation we call linear differential equation. Okay, so the general form of the linear differential equation, you can write it down this way: dy by dx is equal to alpha x. Alpha x is means alpha is a function, and this function is dependent on x only. Okay, and times y equal to qx. Again, qx is a function which is depends on x only. The way to find the answer for this type of differential equation, we got to rearrange this equation in the form of the mdx plus mdy equal to 0. So the way that I did it is that multiply this equation by dx. Okay, when I do that, I would get dy plus alpha xy dx equal to qx dx. And then I put term dx and dx together, then I would get alpha xy minus qx times dx plus dy equal to 0. And from this, m is equal to alpha xy minus qx, and n is equal to 1. Then I do the derivative of m by y and derivative of n by x. Derivative of m by y is equal to alpha x, right? And derivative of n by x is equal to 0. Now it is non-exact equation. So what we got to do is just that find the integrating factor. We want to make this equation to be exact equation. So the way to do that, we're going to find integrating factor. Okay, using the first case, it says that 1 over n times the difference between derivative of m by y and derivative of n by x. Supposed to be the function of x only, right? So we get alpha x, which is a function of x only. Then we can find the integrating factor. Integrating factor is equal to exponential of integral alpha x dx. Okay, that is the integrating factor for the linear differential equation. Okay, and then we multiply the integrating factor into our differential equation. Then we get like this. Okay, and the left-hand side is just equal to derivative of integrating factor times our variable, which is equal to integrating factor times qx dx. To do integral for both sides, we plus c constant. we would obtain what? The integrating factor times y equal to integrating factor qx dx plus c. So our y equals 1 over integrating factor times integrating factor times qx dx plus c. So if you know what's the qx, what is the integrating factor, then you would be able to find the solution for this type of differential equation. Let's take a look at this example. Is this equation a linear differential equation? Is this equation is a linear differential equation? Okay. And the thing is that if you want to find the answer of this differential equation by using this formula, you've got to rewrite this equation again by making the coefficient in front of the derivative of y equal to 1. Okay, because when we derive this equation, we derive from the coefficient of this term equal to 1. Okay, so if you want to use this formula to be the answer of the differential equation, you've got to make the coefficient in front of the derivative of y by x equal to 1. Okay, so in order to do that, we just divide this equation by x, right? So we would get right, and then from our equation we say that right, so our problem, alpha x equal to what? Alpha x equal to what? 3x minus 1 divided by x. And how about qx? Qx is equal to x squared times exponential of minus 3x, right? Now, you know that if you want to find y is equal to 1 over exponential of integral alpha x dx times integral exponential of integral alpha x dx times qx dx plus c. You got to be able to find this term. Then you can plug it in here, right? So integral exponential of integral alpha x dx is equal to what? something like this. Integral 3 dx minus integral 1 over x dx, right? The first term, what you get? 3 dx equal to 3x. Integral 1 over x dx equal to ln x. Right? Which is equal to right? So now your integrating factor is equal to exponential of 3x times 1 over x. And then you just plug it back in there, you would get y equal to 1 over e exponential of 3x over x. Integral exponential of 3x over x. What is your qx? Qx is x squared times exponential of negative 3x dx plus c. You have exponential of 3x times exponential of negative 3x equal to 1, right? Right? These two terms times to each other equal to exponential of 0, which is equal to 1. Now you have x squared divided by x, which is equal to x. Inside, you got to do integral first. You would get what? X squared over 2. That is the answer. We just use the formula that we derived from finding the integrating factor and making the equation to be a exact equation. That is the way to find the answer for the linear differential equation. Any questions? For this line, if you see that the term of exponential of integral alpha x dx, if it is make you feel uncomfortable, like you don't want to look at in the term of exponential, you can write as a mu, because this one is an integrating factor. You can write mu instead of exponential, but you know that they all are equal. Okay. Now, another example. Now it's kind of boundary condition problem, but is it linear differential equation? If you don't want to getting confused or anything, just try to make the coefficient in front of the derivative of y by x equal to 1 first before you decide anything. Okay?